Good day, students. Welcome to my presentation. My name is Rosalia. I'm taking you through quantitative method 2, higher certificate level, year 2. My contacts on the screen. You can call me for further clarifications. We are looking at measure of central tendency or location. We want to find a score that will indicate the center of the distribution where it tends to be located, and it also tells us the shape and the nature of the distribution. Okay, the nature of distribution is what we call skewness. And then in measure of central tendency, we focus on mean, the median, and the mode. You also need to know how to define them. Mean is the average of the data set. Median is the value in the middle of an arranged data set, and then mode is the number that appears the most. Now, most of you for median, you say the number in the middle. If you say just the number in the middle, is not correct, but the number in the middle of an arranged data set. In central tendency, that is just what I talked about. How do we calculate the mean of an ungrouped data set? We sum up all the values and we divide by the total number of items in the data set. For example, we add 175, 163 up to 165, and then we divide it by 6. Why do we divide by 6? Because the number of items that were provided to be added together to get the mean is 6. And then we get our answer. Remember to put the unit of measurement as indicated in the question. The median, you have to arrange your data set in ascending order from the smallest to the largest. Take the number in the middle, and then that is your median. Sometimes you have two values that divides the data set into two equal parts, so you have to add the two values together and divide by 2, and that will give you the median. And this always happens when the data set is even, meaning the number of items in the data set takes on an even number. We have 8 items. Are they 8? 2, 4, 6. They are 7. Okay. Now, if you look at what this, what I have indicated on the screen, where I circled in red 2 values, those values are only 6. Because there are 6, there's no number in between exactly, but 2 numbers divide that data set into 2 equal parts. So we add 6 and 2 together, it gives us 8, and then 8 you divide by 2, and it will give you 4. Okay? Then mode is the number that appears the most. Now if we look at 12, 12 appeared how many times? 4 times. So that is the mode. 11 appeared only 2 times, which means 2 is not greater than 4. 4 is the highest, so the mode is 12. You can try this and see, and the answers are there. We move on to group data. The difference between ungrouped data and grouped data, I have discussed it in my previous presentations. I want to give you the codes of the other presentations that I have done. You can go to those videos and watch. Only concentrate on the things that are on your course outline. The ones that are not part of your course outline, it might be part of the other course outline, but you can watch them and listen to those presentations there, especially mathematics and quantitative method 1 and 2. Those mathematics and quantitative ones are similar, but for quantitative method 2, there's a bit of things that you can find in quantitative 1 or in mathematics, but you can look at quantitative methods for the degree. I've talked about things that are also applicable to you. Okay, how do we calculate the mean for the group data? When you are given the group data set, you are only given the the interval and the frequency. So for yourself, you need to add a column of midpoints. How to find the midpoints is to add the lower limit and the upper limit and divide it by 2. Okay? Then for the mean, you'll need to multiply all the values of the midpoints with the corresponding frequencies, and then you add them together, and then you divide by the sum of the frequency, and that will give you your mean. Okay, now what some of you does, you just concentrate on the frequency, you add 4 plus 12 plus 20 plus 14, and it gives you 50. You divide it by 4, and then you get the answer. That is not correct. Remember, there's another column on the other side that shows you the intervals, and from the intervals, that is where you find the midpoints, and that is the correct way of doing it. Now you also get a table as shown on the screen, and you're asked to calculate the mean, the median, and the mode. Now how do you do it? You use the formulas. The formula for the mean is the one on this slide, and then for the median is what is on the current slide. You can see you are given L plus C, 0.5 multiply by n minus fc divide by f. Look at that division and see where it ends. Do not stretch it up to the beginning, otherwise your answer will not be correct. Okay, now L is defined there, the lower limit of the median class. C is the class width. N is the sum of frequency, and then fc is the cumulative frequency, and f is the not cumulative but just frequency of the median class. Now which one is the median class? The median class, you find it by taking the summation of the frequencies. If you sum up the frequencies, 3 plus 5 plus 7 plus 3 plus 2, you get 20. Then you take 20, divide it by 2, it will give you 10. Now, how do you use this 10? You have to create a column of cumulative frequency. The cumulative frequency, you are accumulating things on top of one another. So 3 plus 0, you get 3. 5 plus 3, you get 8. 7 plus 5 plus 3, you get 15. And just familiarize yourself how to get the cumulative. Now the 10 that we got, you go to the cumulative column, you look for the first value greater than or equals to 10, and that value is what? 15. 15 belongs to which class? 15 belongs to the class of 10 to 15, so that is your median class. So what is the lower limit of that class? Is 10. What is the class width? The class width is the difference between the lower bound and the upper bound, or the lower limit and the upper limit of the class intervals, and they are always equal. And in this example we are working on is 5. N is the total number of the frequencies, and FC, the cumulative frequency of the class before or above the median class. The median class falls where? It falls where 15 is. The cumulative 15 is. What is the cumulative above 15? Is 8. And that is what I gave you in the definition. And then the frequency of that median class is what? Is 7. So you are going to have 20 divided by 2. You have to start with the brackets because you have to follow bed mass. Okay, then 20 divided by 2, you get 10. 10 minus 8, you get 2. 2 you multiply it by 5, you get 10. 10 you divide by 7, you get 0.43. Not 0.43 but 1.43. 1.43 you add it to 10, you get 11.43. Go through and understand those because they are very important. They will always come in your assignment and also in your exams. Okay, and then mode. Mode is the class model class is the class with the highest frequency. How do you know which one has the highest frequency? You go to your frequency column, you see that 7 is the highest, then 7 belongs to which class? It belongs to class 10 to 15, so 10 to 15 is your model class. What is the lower limit or the lower bound of that class? Is 10. What is the class width? Is 5. So D1 or triangle 1 is the difference between the frequency of the model class minus the frequency of the class above, and D2 is the frequency of the model class minus the frequency of the class below, and that is what you get. And if you solve that you get that your answer is 11.67. We move on to measure of dispersion, where we want to see how spread out our data set is. You will always be required to calculate the range, the quartiles, interquartile range, quartile deviation, variance, and standard deviations for both group and ungrouped data. So the range is just the highest value minus the lowest value. And then the quartiles, we have 4 quartiles. Quartiles are values that divide the data set into 4 equal parts. The first quartile is the 25th percentile, quartile 2 is the 50th percentile, and quartile 3 is the 75th percentile. The interquartile range is that the difference between quartile 3 and quartile 1. The quartile deviation is the difference between quartile 3 and quartile 1, and we divide that by 2. How do we find the quartiles? We have simple formulas. N plus 1 divided by 4 will give you quartile 1 position. 3n plus 1 divided by 4 will give you quartile 3 positions. We usually concentrate on quartile 1 and quartile 3 because we get interquartile range and quartile deviation from there. But quartile 2 is also important, and quartile 2 is always equals to the median value. Okay, now for this example that you are given, if you calculate the position of quartile 1, you are going to find 2.5. Your answer will be 2.5. That means you have to arrange your data set in ascending order. But in this example, the data set is already arranged for you. Okay, so what is 2.5? 2.5 is a value exactly in between 3 and 2. So you are going to take the value on the third position, which is 6, add it to the value on the second position, which is 5, and add them together and divide by 2, and that will give you 5.5. Why are we taking 5 and 6? Because 5 and 6 are the values that put 2.5 in the middle. Why is quartiles important? Quartiles tells us the percentages of the outcomes. Let's say this way, the scores obtained in a test. Then what does 5.5 mean? It means 25% of the class got below 5.5 marks in that test. And then for calculating quartile 3, you get that they are on the 7.5th position. What is on the 7th position is 30. What is on the 8th position is 35. We add 30 plus 35 together, we get 32.5. That means in that class, 75% of the students got below 32.5 marks. Okay, and this is just what I was talking about. Interquartile range is the difference between quartile 3 and quartile 1. And then if you do that, you get the answer of 27. And then if you have 32.5 minus 5.5 and you divide it by 2 to get the quartile deviation, you are going to get 13.5. For the standard deviation, the formula is as shown on the screen, but if you can't see it clearly, I've written it somewhere for you so that you can see it clearly. And this is the formula. It says variance, which is S squared, is the sum of the deviation x values minus their mean. You square them and divide by n minus 1, and the standard deviation is just the square root of the answer that you get as your variance. These are the steps that you can follow, you can read through. They are very simple to understand. We look at an example. Now, when it comes to standard deviation, if you look at the formula on the screen and the formula on the paper that I have written down, the one on the screen is only divided by n, but on this paper that I have written down, it's n minus 1. The one that you divide by n only is for a population, but the one you divide by n minus 1 is for a sample. But in quantitative method, we are always using calculations based on a sample. Why? Is because we cannot be able to research on the whole population because of money. It will cost you a lot of money, and it will also cost you a lot of time for you to finish that study. So all the calculations that you have to do when it's an ungrouped data set, divide by n minus 1. Okay, and then Another example given there, how to calculate the standard deviation, and we come to some interesting part of quantitative methods. We want to look at correlation. In correlation, we want to know if there is a relationship between two or more variables. If there is a relationship, what type of relationship does exist between the two variables? Is it a positive relationship or is it a negative relationship? A positive relationship will mean that when one variable is increasing, the other variable also will increase at the same rate, but when they are indirectly related or negatively related, when one is increasing, the other one will be decreasing. How do we calculate correlation? We can see correlation through a scatter plot or by calculating the Pearson correlation coefficient, and also by calculating the Spearman-Ranks correlation coefficient, or we can use the method of least squares. All these four, they are very simple, and if you research on them on Google or YouTube, you can get more examples. It will all depend on you. Do you take time for you to go to read on your modules or not? Do you seek for help or not? Okay? Correlation, as I said, is the degree of relationship between variables. Now, the correlation values lies between -1 and 1. Where -1 means the variables are perfectly negatively related, meaning when one is increasing, the other one is decreasing at the same rate. When one is increasing and the other one is increasing at the same rate, but in the negative direction. Whereby a +1, these two variables are related in a positive way. When one is increasing, the other one is also increasing, but at the same rate. But you can get a correlation of 0, meaning that there is no relationship between the two variables. Anything close to -1 is a strong negative relationship between the variables. Anything close to +1 is a strong positive relationship. Anything close to 0.5, that is a moderate relationship between the variables. Okay? This is a scatter plot that you are seeing on the screen, and it's easy for you to draw it. And then the Pearson correlation, Pearson correlation coefficient, which is also known as the product moment correlation coefficient. The formula is given as on the screen, and I hope you can see it clearly. R is equals to n sum of xy minus sum of x sum of y divided by the square root of n sum of x squared minus sum of x to the power of 2, you put it in bracket, multiplied by n sum of y squared minus sum of y to the power of 2. That is how you calculate the Pearson correlation coefficient. Okay, it just means that the variables of x and y are multiplied together, and all the results that you get, you sum it up and you multiply by the total number of values that you are given. This is the sum of x, the sum of y. You can research on these things and they are easy to understand. You can also call me for help. And looking at this example, we want to know if there's a relationship between sales and advertisement. If you think about it, there is a relationship between advertisements and sales. The more you advertise, the more sales you make, isn't it? Because when you advertise, more people get to hear of your product and they will come and check it in store. If it's affordable, then a lot of people are going to buy. So the more you advertise, the more sales you make, which means you can see that sales depends on advertisement. So your sales will be denoted as Y because it's dependent, and X will be denoted as X because it's independent. Okay, then you can see there we squared In the third column, we squared the x's, we multiply the x with the y. In the fourth column, in the last column, you squared the y's, and then you have the totals in the last row of the table, and you substitute it in the equation, and the answer was found to be 0.81. This is close to 1, which means there is a strong positive relationship between the two variables, which is sales and advertisement. The Spearman rank correlation coefficient. The formula is as seen on the screen: 1 minus the summation of d squared divided by n open bracket n to the power of 2 minus 1. Now most of my students ask me, what is that 6? Where does the 6 come from? The 6 is part of the equation. Now to do the Spearman correlation coefficient, as it's stated in its name, you have to rank the data. You rank the data from the highest to the lowest. The highest you give it 1, the second highest 2, the third highest 3, and it goes on like that until you get to the last one. After that, you have to get the differences of the ranks as shown on the screen, and then we get our answer to be 0.8. 0.8 is also a strong positive relationship between the two variables that were given. Okay, that is another example. How to interpret: if you get 0 to 0.19, very weak. You get 0.2 to 0.39, that is still weak. The other one is very weak. This one is weak, moderate, strong, and very strong. But this will apply to both negatives and positive results. Either you get a negative answer or positive answer, but it's within those range, then you can interpret it as such. And then we move on to simple linear regression. Here we want to fit a straight line equation as shown on the screen. You want to find the value of A and the value of B so that you can use the line to estimate for future outcomes. And those are the formulas, and this is how the question comes, and this is what you need to compute. Remember, this is only what you are given, but you have to add this column so that you get all the variables that you need to substitute in the formula so that you can get your variables. You always have to calculate B first so that you will use it in A. You need to find the value of B for you to get A. Now, if your B is wrong, your A will be wrong, your straight line will be wrong. Okay? For further readings, you need to look at binomial distribution, Poisson distribution, and normal distribution. This is very important for your assignments and for your exams. Okay? Remember, there are earlier presentations that I have done, and specifically look at the one for degree. I have covered some of the things that I did not cover in your presentation, but these things are similar to one another. You can watch them, and also in mathematics there are some topics that are also similar to yours, and maybe I've covered those topics. Please make sure you go through and you get ready for your exams. I hope this will be very helpful in your assignments and also in your exams. And call me if you have questions.